thank you everyone for joining for this webinar. I think let's get going. We waited now. So hope you all are safe at home. A quick introduction about myself. I'm Sheetal Maikar, taking care of pre-sales and marketing at NSEIT, and I will be the host for this webinar. We would want to keep this webinar completely interactive. So few tips before we start. You can use the chat tab at your window to post any questions, and we will be happy to take up at the end of this session. While posting question, please mention your name and also the name of the speaker whom you would like to address this query to. We will try to ensure that all your questions are addressed during the session, but in case we run out of time, please post your email address on the chat window so that we could get back to you after the seminar. And after this session, we will also be sending you a feedback link. So we would love to get your feedback in terms of what do you expect more in such kind of a session, so that we could cover those aspects in future webinar series. Having said that, I think we have two speakers today for this webinar. Let me introduce you to them. One is Sanjay Bhavanani, who heads the infrastructure and operations at NSEIT. Sanjay comes with extensive experience of 22 years in the IT industry. His area of expertise includes global service delivery, planning and budgeting of IT operations, key account management, service transformation, transition and vendor management. And apart from that, Sanjay has sound experience of working across geographies with multiple stakeholders and customers. He possesses insightful knowledge of working with customers in various domains, including BFSI, manufacturing, FMCG, retail, real estate, telecom, travel, aviation, and IT. The second speaker that we have is David Wright, who is a partner solution architect at HashiCorp. David is responsible for the technical engagement with the partner and cloud provider across APJ. He has spent a large amount of time working with partners to create solutions that solve business problems and helping ISP and partners leverage the cloud to create and market their products. David has helped build the ICV's business in the cloud. By applying the skill that he has developed in the technology industry, he has helped develop, design, and implement some major technical projects with significant customers that have proven technology can be the key aid to the business if the business needs are understood very well. So having introduced your speakers today, let me go through the flow of the discussion. The flow of discussion is of course, the topic introduction of the webinar today, that is infrastructure as a code, and why do we look at infrastructure as a code as an important aspect today. Quick introduction will be given by Sanjay about NSEIT, and a few words about partnership with HashiCorp. Then David will take us through the Terraform as a tool which can be utilized in the infrastructure as code, and then we'll showcase some demos to you. A practical demonstration is very useful for you to understand the topic of this webinar, and of course then we'll open the session for question and answer. So currently we know that historically all managing IT operation has been completely a manual process, and people would physically put servers in place, configure them. When they're configured and the correct setting is required by the OS application is set, then the people will start deploying the application. And surprisingly, not that its pain areas were very evident that there was high cost involved. There is almost less or no scope scalability or for scalability and agility, because after that the manual configurations were very with the system administrator would desperately trying to set up the service to manage the load, etc. So we all know this problem. There was completely inconsistency. Imagine several people manually deploying the configurations, and having this pain points, I think some flexibility was needed, and that's where infrastructure as code was the practice which came into existence, which simply to put it, is manage your IT infrastructure using configuration files. It sounds very simple. So just a 5 steps: code, version control, code review, integrate, and deploy. And by employing infrastructure as code, you can deploy your infrastructure architectures in many stages. That makes the whole software development lifecycle more efficient, raising the team's productivity to new level. And having set the context for today's webinar session, I'll hand it over to Sanjay, And Sanjay can then quickly give an introduction and we can get going on the seminar. Yeah.
Thank you, Sheetal, for the introduction and setting the context.
Yeah.
And I will start off by spending a couple of minutes talking about NSEIT and my business unit, that is Infrastructure and Operations. We also lazily call it I&O, our capabilities and what we have to offer to our clients. NSEIT is a strategic IT partner and a 100% subsidiary of National Stock Exchange of India Limited. We are an agile organization with over 1,600 employees and presence across 270 locations pan-India. NSEIT is adding business value to 150 plus customers globally, including 6 of the top 10 financial companies in India. We are razor focused on banking, financial services, and insurance industries. We deliver new age services for this industry enabled with app infra modernization, data analytics, automation, and cybersecurity. Now coming to my business unit, you can see that on the right-hand side of this slide. Infrastructure and operations has gained over 20 years of experience since the inception, and along the way built a strong customer base of 100 plus clients. Since our thrust area is BFSI, 90% of our clients are in this domain. Of course, with that being said, we are not averse to non-BFSI business. After all, any business is good business. And do have customers in other domains also, like telecom, oil and petroleum, pharma, aviation, including government bodies like T-Board and the Haryana Urban Development Authority. Now, we all know so far that it has not been a good year financially due to the significant impact of the COVID pandemic. Encouragingly, infrastructure and operations has been off to a good start with a phenomenal growth of 40% in first quarter as compared to the previous year. We are an agile and growing organization with customer engagements that are objective and outcome focused, having a success rate of 85%. Now, while one part of our business is concentrating on the traditional IT services, there is another part that is focused on the niche and next-gen IT services, like infrastructure as a code, multi-cloud management and orchestration, workload automation, and AI-based monitoring and analytics. In order to enable and accelerate this business, NSEIT has partnered and or created centers of excellence with OEMs like HashiCorp, of course, Embotics, Morpheus Data, OpenStack, BMC, and ServiceNow. Also, last but not the least, Elastic as well. You can see the logos on the right-hand side. On that note, moving on to the next slide. Now, this provides a view of the spectrum of services that we are offering to our customers. Starting from the first one on the left, in digital workplace services, besides the standard IT support, we provide omni-channel services like cloud-first and device-agnostic approach for enhancing user experience. Another important aspect is driving cost and operational efficiencies, which we all know is a constant battle in our line of business. So we do that by reducing contacts using bots, RP, and automation tools. We are doing data center-based network services, LAN-WAN monitoring, and management for leading financial institutions. Just to share an example with you, we have set up an infrastructure monitoring solution provided by Elastic for India's leading capital market player, managing up to 50 million events per day. The solution has unified data from a variety of sources, including logs and metrics, and an agile and streamlined IT operational analytics ecosystem. Next is the data center and cloud advisory, transformation, and operate services. Again, to address the omnipresent impact of COVID-19, there has been a surge in demand from customers for migrating their infra from on-prem to cloud. We were instrumental in migrating T-Board's high availability application infrastructure from on-prem DC to cloud. In fact, their award-winning T-Auction platform on this infra is developed and managed by NSEIT. There are over 5,000 plus COTS commercial off the shelf and customized applications being supported for National Stock Exchange and other customers. And we are doing both application monitoring and operations for them. Amongst other things, we are revamping the grievance management application of India's leading insurance regulatory body in high availability and high fault tolerant mode. Last but definitely not the least, We have combined the strength of our deep BFSI domain expertise with our partner OGIS to provide a comprehensive set of services. We are providing security services in areas like identity and access management, security verification, and security engineering. Moving on. So these are some of the demographics of our support base. I think the slide is pretty much self-explanatory, but I will summarize. We have supported over 2.7 lakh IT devices and applications for over 100 plus customers, maintaining a consistent customer satisfaction index of 90% and above. Moving on to the next slide. Now here's a snapshot of our customer logos, both in BFSI as well as other sectors in the industry. You can see the latter part in the fourth panel here. Just to quickly rattle off a few names, we have State Bank of India, Reliance General Insurance, and Kotak Bank as part of our clientele. So on that note, I'm going to pause here and hand over to my colleague, David. He's going to talk about HashiCorp and why Terraform is the logical choice for infrastructure as a code. Over to you, David.
Thank you. So just some background around HashiCorp. We are a relatively new organization. We were founded in 2012 by 2 research graduates. We're now an organization of over 900 employees. And those research graduates, when they were working, they were fortunate enough to be working against the early elements of the cloud. And what that meant for them was that they started to come up against some unique challenges. And as they solved the problems for those unique challenges, so they saw an opportunity to create products. And those products developed into our product set that we have here, Terraform, Console, Vault, Nomad, Packer, and Vagrant. 2 of those are purely open source, and 4 of those also have an enterprise element. Today's conversation is going to focus predominantly on Terraform because obviously that's around the infrastructure as code tool. Now we know that cloud is being driven and we know that cloud is being adopted. So why Terraform and why use it? Well, we've seen it that the adoption of Terraform helps reduce infrastructure costs. It definitely increases operational efficiency. So and not only can you deploy infrastructure with Terraform, but you can also use it to update and make changes to infrastructure, which means that you have a tool that not only is used for deployment, but also has that day 2 operational perspective. And so what HashiCorp has done has put together a cloud operating model. And this cloud operating model speaks to the how of delivering cloud. Many of the cloud providers obviously have their shared responsibility models and deliver the why or the positioning around cloud. But HashiCorp has very much positioned itself as a multi-cloud player and an enabler of driving that ability to adopt a multi-cloud strategy for enterprise customers. And what that means is our tool sets meet the challenges across kind of 4 key areas. So provisioning and operational, which is what we will be talking about more with Terraform. Security and secrets management and PKI delivery via Vault. Connectivity through service mesh and service registration using Console, and a runtime and scheduler using Nomad. And that allows flexibility across all of the major cloud providers, but it also really can address the on-premise component or private cloud. And so now you have a singular tool that you can use and invest in to develop across all of those platforms. So as you start to look and think about creating a multi-cloud, the challenges that you used to have around fixed infrastructure, knowing all the IP addressing, knowing the VLANs, knowing what the individual servers look like, obviously those challenges are now being enhanced as you move to the cloud, and those fixed parameters don't exist anymore. And what we're seeing is that organizations that are starting to see the benefits of digital transformation are starting to look at ways to be able to compete across their market and looking to drive more and more digital transformation, are then actually driving the need for more and more change within their infrastructure. And we're even seeing that the adoption of cloud is then being pulled back into what is becoming known as private cloud or their local data centers, so that the changes that they want for their applications are being forced onto traditionally on-premise components that don't have that necessary API shift. And so what that means is that we're seeing applications becoming more ephemeral. We're seeing lots of different environments and different deployment platforms required to deliver your application on. And we're seeing the need for it to be distributed and delivered at scale. And this shift towards multi-cloud is where HashiCorp really has been addressing those challenges. So in this move from the dedicated and static world into the private cloud and multi-cloud world, we're seeing a need for developers to actually be able to integrate security and networking and delivery into their code pipelines. We're seeing the challenges of being able to orchestrate and deliver a tool set that can work across not just multi-cloud but hybrid cloud, and deliver capacity across lots of different infrastructure parameters. We're seeing the need for security to be built in. So as zero trust or low trust networks are becoming the norm as the adoption of cloud and as infrastructure moves to the cloud. So how do you actually build in and create security and governance, compliance and regulatory controls around, and build those into your delivery capabilities? And how can you connect these services across multiple services and build workflows that allow you to deliver those services easily? And what we're seeing is this is really where HashiCorp and our toolset are becoming becoming very strong. So we know that all of the cloud platforms have native tools, but those native tools lock you into a particular story and a particular vendor, whereas our tooling is specifically designed to meet the challenges and learn the tooling once and be able to then solve those same challenges across multiple delivery platforms. And so with that, we're going to take a deeper dive into looking at Terraform and go through some of the Terraform concepts. So one of the big important parts that we see with Terraform is this ability to actually integrate that governance and compliance and being able to manage your workflow from a singular tool set. And this also goes towards being able to then build capabilities around being able to deliver self-service infrastructure for users. And these two kind of key concepts are the things that we're seeing real traction with our enterprise customers. And this is leading to, seeing over 100,000 downloads per week, 300 plus, enterprise customers, and the support from the community, which is where we really see a lot of the strength of Terraform. Over 200 different providers, and a provider is a mechanism to be able to talk to that provider's API. 200 different ecosystem partners that we are starting to work with, and those relationships are only growing. One of the guiding principles that we use when delivering and talking about Terraform is this concept of infrastructure as code. And we've mentioned it here today, but just touching on it slightly as to why it's important is it starts to actually remove the human element, right? The need for humans to be able to physically do something, physically type something, the ability to create automation, the ability to integrate that in with version control. And now you have a mechanism that you can build trust around. And Terraform also allows taking this principle and applies it to its policy as code. So not only can you build infrastructure as code, but we have a Sentinel policies, which are part of the Terraform Enterprise, and that is built into the platform that allows you to then automate and build code sets into that as well. So there are other tools on the market, but most of these tools are focused around OS or configuration drift. And so the difference with Terraform is that Terraform is built as a application or infrastructure delivery tool, and will stand up and build your infrastructure and manage it after you actually have delivered it. Now, obviously there is an overlap in the middle where some of these tools do touch, and they both have capabilities that do overlap. We can provision elements, and they can deliver infrastructure. However, what we are saying is you have one of these tools, you can use it and then focus it to actually deliver what it was built for, which is that configuration management, and use Terraform to actually build and stand up your infrastructure. So it's not necessarily a rip and replace, it's actually a quantifying and and using the right tool to do the right job and get the best performance out of it. And so all of these things go together to actually build this really strong ecosystem. Now Terraform has an enterprise version, but there's also an open source version as well. And that open source wide reach is where we get the 1,200 plus developers who can actually drive features and new requests that then feed into enterprise and provide a really rich and feature-rich ability to deliver what customers need. One of the really important parts with Terraform is its ability to create workflows, and those workflows are based on its modularization. So we use the thinking around don't repeat yourself, so the dry methodology, which allows you to build repeatable code sets that can then be used to deliver outcomes. So in this circumstance, we have code that can be written by the storage team, code that can be written by the networks team, code that can be written by an applications team. Each of them may write their own code. It is then tested, put into a pipeline delivery, and then when an application needs to be stood up, so you can actually deliver that and run that as a workflow. This all ties together with being able to pull things from a registry. So there's a public registry where modules are written for customers that allow for the use of, say, an AWS VPC or an Azure VNet. And you can pull those into then a private module registry to customize that and use those modules again in your code sets to build those into repeatable patterns. All of these things go together to create a tool that provides a single control plane, whether you're delivering that into a private cloud or into a public cloud set. And one of the demos that we talk of later or showed later shows how we can do that across those different multiple environments. But fundamentally, we're looking at how a single technology can be used, pulling in providers and using that broad ecosystem support to then actually deliver API calls and integrate in with different workflow mechanisms, whether that's ServiceNow, GitHub, or a cloud platform, to build a tooling that allows you to now automate your infrastructure from a trusted scenario and trusted platform. And all of these things go together to create a platform that allows you to build governance and compliance using security and Sentinel policies. So Sentinel policies will be applied before your infrastructure is even stood up. So you can now build, and as one of the demos will show, you can now build control around a spend mechanism or where a region is actually being deployed. And you can build that in before your infrastructure is even stood up, which means that you don't have to retrofit security into the infrastructure you're building. And all of these things help reduce your overall risk. You can reduce costs by using Terraform because there is a cost estimation, and you can actually then start to plan what your infrastructure costs will be before they're allowed to deploy. And because you're using this mechanism of repeatability, you now have that increased performance and productivity, which creates multiple workflows. And so some key enterprise features that we like to talk about are the thinking around workflow and not a workload. Most infrastructure tools are built around delivering a specific workload. We think of it around delivering a workflow. And our workspace is tied together to allow you to create these individual workloads, but tie them together to deliver an outcome and workflow. There is massive community support, so over 1,200 contributing members that look at the code. And all of this helps build a strong ecosystem of providers and an infrastructure tool that now has a centralized login and auditing function that means that you can keep watch on what infrastructure is being done. And integrating that watchful eye with your ability to integrate with our SSO and control who has access and what access that and group that can do means that you can now tie in governance and compliance with your cost estimation, your policies as code, and your ability to deliver different providers to absolutely enhance what the user experience is. So as the workflow is built out, so now you can actually deliver those those controlled relevance. And so how do I get started? So there's three kind of mechanisms to consume Terraform. So there is a open source CLI. That CLI is very much focused around the individual contributor and is based around the open source mechanism. But it's one of the things it doesn't do is provide you the ability to collaborate easy and manage that end state. And that's where the cloud and enterprise offerings do. They can then actually take control of that declared end state and our state files, and you can share those between different members without everyone, and make sure everyone is working off of their current state file, and making sure that applications can only be run with the latest and necessary deployment. And these two mechanisms can then be consumed either as cloud, so as a SaaS platform, or as a shrink wrap deployed anywhere in an environment that you want to build. From a customer's perspective, we've obviously got some large and complex environments that we speak to, and these brands have trusted the HashiCorp Terraform to use it as part of their integrated pipeline and integrated services to deliver their infrastructure. And we've seen a growing number of our customers in the top Global 2000 adopting Terraform as a standard. And working with a lot of the cloud providers, we're seeing them actually starting to have customers ask them to work with us so that we can deliver that infrastructure. And with that, I'd like to hand it back to the NIST team and for them to actually show you some of these great scenarios that they've worked out.
So thank you, David. So colleagues, I have a demo video of a use case with different scenarios that I would like to walk you through. These are solutions to some real world challenges that we face in our day-to-day work life. Before we get into the demo, I would set the context on what real life problems we are aiming to solve over here. This use case is about self-provisioning of virtual machines by user with enforcement of controls. Say you want to limit the cost or the instance type using Terraform's Sentinel policy. Now, Sentinel policies are rules, that restrict the provisioning of resources by Terraform configuration. Normally, when you're doing a Terraform run for provisioning, it's a 4-stage process. I will show you in the demo. And the Sentinel policy gets applied between the plan part, where you are gauging the requirement and running the configuration, and the apply part, where the final execution happens and the request gets, the infra gets provisioned or the request gets fulfilled. The use cases also addresses exception handling in case a user exceeds their entitlement in terms of cost or instance type. This helps to solve the problems of productive downtime and failures faced due to manual provisioning of infra by the infra team, and also maintains traceability for exceptions in case of audits. Note that the infra provisioning scenarios are for both cloud and on-prem. We've also included on-prem so that we can demonstrate the viability of Terraform even for on-prem requirements. Okay, moving on. So this is the first scenario. I'll just give a preface here or what would be the flow in this scenario. We have a developer, Kanchan, who needs a virtual server to carry out her development work. So she logs into the ServiceNow portal for raising a ticket. We have used ServiceNow as a ticketing tool, but one can integrate with any API-based ITSM platform. So during the demo, I'll be making a few switches between the front end, that is the ServiceNow portal, and the Terraform workspace. Kanchan, the developer, will only see the real-time status of a request in the ServiceNow portal. Terraform workspace is where the request gets executed in the backend. And of course, finally, the fulfillment takes place in the AWS cloud. So I will pause where required, where there's a need to emphasize on any relevant points that are to be noted. On that note, I'll get started with the video. So here, you have the ServiceNow portal. You can see Kanchan is logging in to her account in the ServiceNow portal. So she logs in. This is her landing page. Now she's going to go and click on the Order Now button to raise a service request for creation of a VM. You can see here, she's going to, she clicks on the Order Now button. So So the ticket is created, the request is getting processed, and you can see based on the request, Terraform workspace is getting created. So this is a notification that Kanchan is seeing in our ServiceNow account. The Terraform workspace is created. And I will just pause here. I think there's a need to provide some additional information. So workspaces are, when we talk about a Terraform workspace, these are basically collections of infrastructure. So the way Terraform manages each collection of infrastructure is with a persistent working directory, which contains the configuration, the state data, and variables. In Terraform terms, these are known as workspaces. So once the workspace is created, you can see the real-time status of the request based on the integration with the Terraform Enterprise tool. Now, in the second pane below, you can see that Kanchan has raised a low priority ticket. And in the traditional way of working, low priority service request, in my experience, normally has a turnaround of 48 to 70 or 72 hours. However, here the provisioning is going to happen in a record time of 10 to 15 minutes. Now moving on. So now we have switched over to the Terraform Cloud user interface. Here it is a 4-stage process starting with plan running. Plan running is where Terraform initializes the configuration and understands the requirement. You can see that happening in the black screen here. Now, once the planning stage is finished, next is cost estimation. In the cost estimation, based on the instance type requested, it retrieves the real-time cost from the AWS cloud. You can see the cost here is $16.20. Now the Sentinel policies check is being executed. We have put a limit of $100. Since $16.20 is well within that limit, the policy is passed. You can see in the highlighted text that both policy checks are cleared. I'll just pause here. Finally, once both the policy checks are cleared, the code is getting executed and the VM instance is getting created in the AWS cloud. We'll allow this to run for a few minutes so that the VM gets provisioned. Okay, this is fulfilled. Processing is complete. We are back in Kanchan's account in ServiceNow. You can see the Terraform apply is finished. Okay. Now we are going to switch over to the AWS cloud and see if the VM fulfillment is done. This is the Amazon Web Services portal. So as you can see here, the VM is created and it is running. So that concludes the first scenario for auto provisioning of a VM. As a side note, you can even have a scenario in a multi-cloud environment, which David touched upon earlier in his presentation, where Terraform can retrieve the cost from various cloud providers. You could have a Google Cloud, you could have a Azure Cloud, along with the Amazon Cloud. And then one can decide based on the costing, from where you want to pick up an instance. So in this way, Terraform gives you a single plane for provisioning in a multi-cloud environment. Also, as you can see, there's hardly been any productive downtime for the developer. She's been able to auto provision the infra, and there has been zero involvement from the infra team, which means it also frees up the infra team to work on more core areas, including enhancement of the infrastructure, rather than concentrating their faculties on provisioning of VM requests. So now we will move to the second scenario. Just pausing here. Sorry, I'll just back up a bit. Okay. Now, this is the second scenario where the self-service provisioning is done beyond the entitlement. Now, we will see how the Sentinel policy checks fail, and then the request goes for a manual approval to Kanchan's manager. Okay, starting off with the second scenario. The initial steps are pretty much the same. Kanchan logs into service now. Now she's going to raise a ticket for requesting an instance type. Clicks on order now, raises a ticket for a web and DB server. This time she has requested for a larger instance type for website, a larger virtual machine instance type for website hosting, which she is not entitled to. So now the Terraform workspace is created in service now. From here, we will switch over to the Terraform Cloud UI. It is the same drill here. Terraform is initializing the configuration and understanding the requirement. Now here we need to pay close attention to the cost estimation and the policy check stages. So the planning is done. Now it's fetching the cost of the instance type from AWS Cloud. I'll just pause here. As you can see, the cost estimation is finished, and the cost for this instance, requested instance type is $154.44. Consequently, the policy checks are going to get failed as the instance cost far exceeds the cost limit we have set of $100. Now we'll see how the checks, so you can see the checks have been failed over here, both of them. You can see them in the highlighted text. So this is a message that, this policy check is failed. I will just pause here as to let you know what we are trying to convey here via this highlighted text. So the requested instance type is m5.large, and here it is telling you in the highlighted text that Kanchan is only entitled to a t2.small, medium, or large instance. So with that, Kanchan is now going to get a notification that a manual approval is required. Just finishing the run here. So you can see this is Kanchan's ServiceNow account. In the highlighted text, you can see it says manual approval is required. So this way, Kanchan is getting a real-time status on what's going on with the request. Now, Kanchan's manager Sanjay has logged in to his ServiceNow account. He's going to review the request and approves it in ServiceNow with a deemed justification on why he's approving it. Now, coming back to Kanchan's account, you can see that the policy override has been approved. You can see it here in the highlighted text. And Terraform is now going to apply the configuration. So switching over to the Terraform user interface, this is the final stage, which is apply running. And the code is being executed for creation of a web and DB server. There's a confirmation that the state version has been created. Switching back to your Kanchan ServiceNow account, you can see the Terraform apply is finished. The request is completed. Now I have highlighted the public IP over here. I'll come to that later. What's the reason for highlighting that? So now we will do a simple test. We will launch a test page in any internet browser to see if the website is running or not. Typing in the address using the public IP. Okay, here you can see the results. The page is functional, website is operational. Here, that guy looks strangely familiar. So that concludes the second scenario. I will just pause here. As an add-on, I would like to say that the reason for emphasizing on the public IP is that tomorrow, if there's a need, we can change the public IP to a private IP if we don't want the server to be accessed from outside. These changes will be saved from a traceability and referenceability standpoint in the Terraform configuration file. So this helps in preventing change-related failures. So if I don't recollect and I need to go back after 15 days and I start wondering what was the changes done on this WebDB server, I can just go into the configuration file and see the record of the change. It will tell me that you changed the IP address of the server from a public to a private IP 15 days back. So that moving on to the third scenario, which is on-prem provisioning of infra. Here the provider used for on-prem use case is vSphere. Normally Terraform is supposed to be cloud provider agnostic or even on-prem agnostic. What really connects Terraform to the resources, the resource engine or the provider at the back is something known, it is known as a provider, which is basically a software interface between the cloud provider or the on-prem provider at the back and your Terraform. In this case, of course, the on-prem provider that we are using is vSphere. Post creation of the virtual machine, we will install the CentOS operating system on it and then the database, Postgres. The installable packages for these are given in the specified file, specified path in the Terraform script. Now I will just run the third scenario. So you can see in the code here that Terraform has been integrated with VMware vSphere for creation of a virtual machine. So the apply command is run from the Terraform command line here, and the script file is running. Here the Terraform API is calling vSphere to create a VM called a demo test. This is the VMware ESXi console where you can see the demo test VM that has been created. Now an installation of CentOS operating system has been initiated. For the sake of understanding and differentiation, we have done a visualization of the user interface for CentOS installation. You will see that pop up. This is the visual interface where you can see the CentOS installation is in progress. All the packages are getting installed one by one. So post installation of the CentOS, we are logging into the server from the command line. Here we are using the root account to log in. Now from here, we are going to initialize the Postgres database. So you can see the Postgres database has been initialized. With this, the setup is complete with the provisioning of the VM, the installation of CentOS operating system, and installation and initialization of the Postgres database. In the highlighted text here, you can see the hardware configuration that we have specified for the virtual machine, which has 2 virtual CPUs, 1 GB of memory, and 20 GB of hard drive. And that concludes our third and final scenario. Thank you for listening. On that note, I will hand over back to Sheetal.
Hey, thank you, Sanjay, and thank you, David. So I think anybody has a question, you can use your chat window and share your questions with us. Meanwhile, David and Sanjay, I already have a couple of questions people have posted, so I will just start. Meanwhile, the others are, gearing up to put their questions across. So this question is to you, Sanjay. Somebody has asked that they already have tools like Chef, Puppet, and Ansible. Can Terraform replace it? That's the question for you.
Okay, so as I demonstrated in the first 2 scenarios, Terraform can do both for you. It can do the provisioning of infrastructure as well as configuration management. Therefore, it can also coexist with the other tools rather than replacing them. But I think it purely depends upon the organization. It's their call, whether they would like them to coexist and use both of them together, or they can just use Terraform.
Okay, thank you very much. I think second question, David, I think I'll go with you for the answer. Can Terraform be used in software-defined networking area?
Yeah, so you can codify anything with Terraform. So if you're using it within that SDN, then the configuration can be used by Terraform to automatically set up and modify settings at that control layer. So because of our integration through our providers and work with Cisco, that allows you to make the necessary API calls to then steer and deliver network changes within an SDN or to an SDN controller, that then drives out those changes through through traditional hardware mechanisms.
Okay, thanks, David. I think the second question also, I'll share it with you if you can just throw light. Somebody has said they're already using AWS Cloud Formation. So he's saying, if I already have AWS, do I need Terraform?
Happy to take that one. Look, I think the story is very much depends on what you're trying to achieve. If you're a completely cloud native platform and you've integrated and spent time operationalizing your staff and training your staff to work on that platform, and that's the only platform you're ever going to work on, and you're never going to use anything else, then obviously using the cloud native tooling makes 100% make sense. However, if you have any mechanism or element that is across either multiple platforms, or you have a regulatory control, or you have a legacy component that you need to actually start looking at and managing, which means that you start into the realm of multi-cloud, hybrid cloud, and multi-platform. So we're doing app modernization and moving into containers. Then that immediately opens up the need for a tooling that can be used across multiple platforms and multiple different environments. And that's where Terraform then kind of clearly differentiates itself from the cloud native. And then add in the value that you get with codification around Sentinel policies, control, governance, compliance, as shown in some of the demos.
Okay, thanks, David, for that answer. I think, Sanjay, I'll go the next question with you.
Sure.
Somebody has a question saying, every time before creating infra provision, can I get to know the pricing from different cloud providers?
Okay, glad you asked that question. I think I, in some form, illustrated that during the demo when we were talking about retrieving the cost estimation from an instance type. While we have used AWS over here, but you can use multiple cloud providers. If you have a multi-cloud environment, Terraform is agnostic that way. You just need the APIs via which you can fetch the real-time pricing. So this makes it easier for the organizations to make a decision about which cloud provider it wants to provision based on the cost pricing.
Okay, thank you, Sanjay. I think, dear participants, if you have questions, I will again repeat, you can use your chat window and just share it across so we can get it clarified. Okay, this question to you, David. What are the benefits of Terraform Enterprise over open source technologies?
So Terraform Enterprise basically allows you to start using collaboration. And so the real value comes when in enterprise, where you have large teams that need to collaborate across different workflows, and the Terraform Enterprise allows you to manage that back-end state. Also, the management of that back-end state then brings into control where the state is held, and the ability to then make sure that any passwords, secrets, AWS keys, or service principals are managed in that one location and are then obfuscated and secured. So securing your state, managing your state, and taking control, plus then integration with things such as SSO, RBAC, policies, and being able to drive and deliver Sentinel policies. So for that governance and compliance part, all of those are the real kind of enterprise features that we see distinguish between the enterprise version and the open source version.
Okay, thanks, David. Sanjay, I think I'll go with you for this question. Where will Terraform get installed?
So there are three ways via which Terraform can get installed. One is the individual contributor, where you just use the CLI, the command line interface. Then, like I had demonstrated in the first and second scenario, you have the Terraform Cloud user interface that can be used. And the third delivery method is if you have an on-prem application, you can do a local installation on a VM and run your Terraform engine from there.
Okay. Thank you very much. I think we are through with the question. Anybody from the participant who has a question, you can post it on the chat window. Yeah, okay, there's one more question which has come. Okay, I think this question to you, Sanjay. Which domains do NSEIT and Terraform have a partnership with?
Okay, domains, I'm not quite clear, if you're, I mean, from a technology standpoint, of course, we are talking about Terraform only here and what we can apply across different technologies. Obviously, as an organization, our thrust area is BFSI. So, primary focus on whatever application we need to do for Terraform is going to be over there. Of course, we're not averse to doing it for other customers as well. So I hope I've interpreted this correctly, what is meant by domains, but in case, the question is not answered, open to, hear further on what the person was looking for.
Sure. I think the participant who has posted the question, I would request if you feel that there is something that we are missing out in this answer, please do let us know. Anybody else from the participant list who had a question which you feel that we should answer in this session, we are happy to take. I think we'll wait for a minute. I think we are nearing the end of the webinar. I think this will be the last question and then we can wrap up the session. Oh, okay. So, Sanjay, I think you need to clarify what is the strategic partnership between the two firms is what the question has been asked.
Okay. So the strategic partner between two firms is, obviously we see a lot of promise in Terraform, the way Terraform can be used across multiple platforms for applying the code. And hence, we feel that, we can partner with HashiCorp to take these services to market, to the India market. Also, considering that, India is a very price sensitive market and, there are a lot of other products out there, which are used for cloud orchestration. But of course, there's a dollar value associated with it. From considering that India is a very price sensitive market, I think, partnering with HashiCorp, we can really get that penetration in the market and give them these service offerings in terms of how they can move away from the traditional way of fulfilling infra, doing the infra provisioning, as well as configuration of infra, which also leads to a lot of configuration drift and inconsistencies, and streamline those operations for our customers to bring in operational efficiencies, reduce productive downtime for their users, their businesses, where users cannot, self-provision infra, and as well as, of course, bring in the cost efficiency as well.
Okay, thank you very much, Sanjay. I think he's also happy. Okay, yes, sure, sir. This is the webinar recording will be available and we will be sending it across along with the feedback link post this seminar to all our participants. So where you can watch this, and very shortly we will also be uploading this recording on the YouTube so you can access it later also. Thank you very much. Anybody else who has a question can post it. I think we can wait for a minute or so, or we can conclude otherwise. Okay, I don't think so. There are any more questions coming in. Thank you very much, all of you, to take time out from your busy schedule and joining us for this webinar. It was very, very helpful. We really appreciate if you have any questions, you can post it in the thank you email that you'll get it very shortly in your inbox. And thank you. That's it. So we'll conclude the webinar here. Stay tuned. We will be coming up with the next session very soon. Thank you. Thank you, Sanjay. Thank you, David, for the really appreciated time and the insights on the subject.
No
Thank you.
Thanks, everybody.
Thank you, everybody.
Thank you, everyone.